8 people and 10 of them have problems with fractions. I think the problem is with me, right? I can't talk to 8 people, I have 10 of them, so I can't have p hat greater than 1. So what's that, 101 divided by 578? Oh, my calculator's busy. And I'll tell you this, percentages go out just like standard deviations, at least 3 places. 0.175? So what's q hat?
1 minus 0.175.
11. So 0.825. Now, do you see how it's plug and chug? It is purely plug and chug now. Here's the formula. What do I want to use? I'm trying to find the constant interval for a percentage. Do I want to use this one? No, it's got means in it. Oh, this one's got percentages in it. Well, shit, that's the one I want to use. I mean, that's the level of how to determine what to do when. So p hat, give or take, this many steps. So in this case, this is acting like the standard deviation in this case. This many standard deviations away from what my middle is supposed to be. That's my best guess for the middle. So p hat, we've calculated it to be 0.175, give or take. The z-score we got for how confident we want to be is this. Square root p hat times q hat. I'll tell you what, I'm going to show you how to put this in your calculator. Because one of the biggest mistakes people make is trying to plug this in the calculator when they do it wrong. I don't know if you guys have watched that video. Let's just put that would be good. Jeff, I seen through glass. No. All right, so real quick. To put this in the calculator, I think I told you last time, you really should figure out this error first. All right, with the example we did last time. Figure out the error first, because I'm going to add and subtract that from this. And that's really a really kick-ass, cool, easy memory thing to do. Not memory, but memory. Oh, which one was it? Okay, good. All right, so to put this in, for just the error, so you put 2.575 times the square root. Let me start right there. How many of you guys, when you do the square root button, it looks just like mine? How many of you guys are playing along with me? A few of you guys, okay. How many of you guys, when you hit the square root button, you have a parenthesis open? Okay, all right. Those of you with the parenthesis that opens, do not close that parenthesis until you're done. If you close it here, you come out of the square root. When are you supposed to come out of the square root? Way down here. That's the number one biggest mistake people make. This parenthesis that opens is telling the calculator all the crap that comes after this is inside the square root. So if you close it, you're out of the square root. The newer calculators that, being a geek, I am jealous of, and this is now the emulator's been updated, I guess. They just make the bar go bigger. That kicks ass. So 0.175, see that bar getting big? Times 0.825 divided by 578. So for those of you that had a parenthesis, should be the first time you're hitting that closed parenthesis set is right there. So let's see if we all get that same answer. So can somebody tell me what that number represents? Okay, I like that. It's a very quick, concise answer. Error. This is true. It's the error. Now tell me more. Careful. No, we know that p hat is the percent from the sample population. The error is how much I think that this is off by. At 99% confidence. So how likely is it that I'm wrong, that my error is bigger than this? How confident am I about this? 99% confident. How likely is it that this is wrong then? 1%. Personally, I can live with a 1% chance of being wrong. That's better than normal for me. So the error we got was plus or minus 0.0406, right? So 0.041 we can round it to. A real quick little thing. If you do 0.175 minus, you can just hit the second negative and that'll be this last thing on screen. But let me show you something even better. Shit, some of you guys probably hit enter after that. If I hit store, this button right here, store that in X, I could just do 0.175 minus X and 0.175 plus X. That way I'm not rounding till the end.
What?
All right, don't freak out.
Where'd you get the X?
Don't worry. So I just did the work here, right? There's the error again, right? If I hit store right there, stowaway. If I hit store in X right there, there's my X button. The most accessible variable on the calculator is right there. Now X contains that. Why is it good to have it? Because I have to use it a couple times. 0.175 minus X, 0.175 plus X. Cool. Oh shit, I knew something looked weird. 175 plus X, thank you. So it's in between 13.4% and 21.6%, right? So we are, oh shit. We are 99% confident that the true percentage smokers at Grossmont is between 13.4% and 21.6% roughly. So this is kind of data we'd have to report if some accreditation committee, and it wouldn't necessarily be about smokers obviously, but it might be about, well, what percentage of your students earn degrees? Or what percentage of your students withdraw from courses or so forth? And we only had time to look at a sample of our students. We can give them a confidence interval and say that 99% confident and the most is this. So there's only a 1% chance that we're wrong. Just to show you real quick before we do this, I know I've mentioned this. I don't know if I put this up here. Come on, internets. Gallup.com. It's just one of my favorite. The reason this is one of my favorites, let's see what it looks like. It'd be good to look at here. Let's look here. Americans back budget deal but declare no winner. So 6 in 10 Americans. Let's see. So if you click on an idea, they give you all the data. But now look at the very bottom. They tell you survey methods. Now look at this, and they tell you like they did telephone interviews, how many people they talked to, blah, blah, blah. Now look at this sentence. That sentence now makes a hell of a lot more sense to us, hopefully, than it would have 2 hours ago. All right, so for results based on total sample, one can say with 95% confidence that the maximum margin of sampling error is plus or minus 4 percentage points, just like we got here, right? It's not the same data, by the way, but they just happen to get plus or minus 4%. Are you guys kind of with me? I mean, so it's kind of cool to see that what we just did here is the same exact shit that would be done for a real-life, totally acceptable survey, statistical analysis of something, right? I mean, that's important for you guys to see. We're not just doing bullshit stuff, even though I made this data up. Here's data that wasn't made up. They did the same math on it. It's the same exact. You can understand it now. All right, so here's what I want you guys to do. tell you what, don't worry about 1 part C yet. Want to make sure you get the basics down here. Done. Just read it. Huh? Oh, 6. Yeah, I'm glad you told me that. So you guys, real quick, before you get in there, if I wanted to figure out like 93% confidence, that's part B on there. I could draw a 93% confidence interval. There it is, right? How do I figure out the z-scores? What area is out here? 7% total, right? So there's 7% total area outside of there. And on one side there would be that cut in half. Are you guys laughing at my...
No, I keep saying numbers, but not the same.
Sorry?
You're saying 3.5, 3.5.
Oh, yeah. So 7%, and then you cut that in half. 3.5. You're fine. Right? 0.35. And if you look that 0.35 up, that'll be the z-score you need. Now, the book uses a symbol that looks like this. The book uses this. And that makes it look like you're supposed to do something, divide something, and all this crap. This is the z-score that's related to this area. Alpha is the area outside the middle. So alpha would be the 7%. So now you see why it's z-score associated with alpha divided by 2. Because how would we get the z-score? Cut this in half, wouldn't we? And then look that up. So I really wish they wouldn't do that because it makes the formulas look much more complicated than they really are. It's just like the name of the z-score. It's not any z-score. It's the z-score that goes with this. That's why they put that there. So whenever you see that symbol on your z-score, take it the hell off. You know where the hell the z-score comes from. You don't need a little name tag on it. It makes the formulas look worse than they really are. I obviously have a problem with that. All right, so let me know. Everybody got a copy, right? Did you not get it? And one more, okay. I guess can kill you.